Look at this: planets, physics, collisions, a live score, a windscreen, a fully playable space shooter built and run by a local AI model. One prompt went in, 0 lines were hand-edited, and it is flying right now. This video is the receipts. This is Qwen 3.8-27B showing what it builds. Animations, games, and interactive visualizations, all generated, all tested, and all executed on a home-built machine. Let's see what it made. First, the box. The model runs in FP8. Its native precision, no quantization, split across 4 RTX 3090s with 96 GB of memory. No cloud, no API key, no per token bill. A 27 billion parameter frontier-class model living in a rack next to the desk. Every demo in this video was generated on this exact machine. Demo 1, the 2D platformer challenge. The prompt is 5 words: build a small platformer, 1 file. Watch the agent inside Visual Studio Code plan the levels, write the canvas rendering, build the physics, and fire the game up. Pixel Peak runs to its flag on its own. Nobody fixed a single line. It scaffolds the file, writes the physics, and plays the build back to itself before it shows you anything. Then it iterates and ships a complete game from 1 sentence. Now the A and B same 5-word prompt, different harness. In Open WebUI with no editor and no integrated terminal, the model ships a second, genuinely different game. Ember Peak with torch lighting and a sunset finish. Ember Peak even gets its own art direction, a torch drifting ember particles, a sunset. The model reinterpreted the prompt. It did not copy the first game. 2 harnesses, 1 prompt, 2 playable games. On the previous generation, roughly one of the 2 would have needed hand fixing. 2 out of 2 playable on the first try, with 0 manual edits. That is the harness story, and it is the headline of this release. But games are demos. This next one is the artifact. Over a sustained working session, the same model produced a live simulator of a hybrid electric locomotive, a diesel prime mover in the megawatt range, a 2 megawatt-hour battery pack, regenerative braking, and a classic diesel-electric unit for comparison. The dashboard is an animated cutaway with real-time gauges for torque, battery state of charge, region current, and resistor dissipation, all updating live from the simulation state. It runs entirely in the browser with no backend. The agent wrote it, debugged it, tested it, and shipped it without ever leaving the box. This entire engineering instrument is 1 static HTML file. And you are seeing the Agentic Loop compressed. The prompt goes in, then the model plans, writes, tests, and iterates until the artifact stands on its own. That is hundreds of tool calls, and each one lands in about 5 milliseconds. Each tool call is a round trip the model makes for itself. Read the file, run the check, patch the bug, try again. That latency is what makes the whole workflow feel like a coworker instead of an API. And the newest build is this, Aetherline. A full cockpit sim, a starfield, procedurally placed planets, collisions, scoring, and a flight model that responds live. Notice this is not a screenshot or a mock-up. The AI is actually flying the ship. Every frame you are seeing is the ship model answering its own input. And it wins, the score climbs, the final contact happens, the explosion runs, and the windscreen lands on its own. Nobody pressed a key. A model on a 96 GB home-built machine, generating a complete 3-dimensional game, and then playing it through to the end. One number quickly for the skeptics. DeepSWE 1.1, the jump from the previous generation to 3.8, 13 to 42. 2.5 times the score on the hardest agentic coding benchmark in the family. That is not a version bump. That is a different product wearing the same skeleton. The box, in short, FP8 weights the model's native precision, about 25 gigabytes per card, a 262,000 token context held live in cache, 74 tokens per second, flat all the way up to 1,000 token outputs with first token around 5 milliseconds, consumer hardware, frontier-class behavior at 0 per token cost, and none of it leaves the building, your data, your box, your tokens, your cost. There is a whole research post behind this. The complete benchmarks, the class comparison, and the cost math all live on ThinkSmart.life. Qwen 3.8-27B, running local right now on 4 second-hand consumer cards. Go build something.